we have the function 1 dividing by x plus 1 square, which can be rewritten as x plus 1 to the negative 2. And this is what the graph looks like. And we want to find the intervals on which the function f of x is increasing and decreasing. So looking at the graph, it looks like right here this is negative 1. And then from the left side up to negative 1, the graph is going up. And then from negative 1 to the right side, the graph is going down. So we're expecting to find that the function is increasing on the interval from negative infinity to negative 1. And then the function is decreasing or going down, or the graph is going down from on the interval from negative 1 to the right side, which is infinity. And so first, let's find the derivative. So we can find, we think it's negative 1, but we'll find the derivative and then find the critical numbers. And then that will tell us if this is indeed negative 1. So here we have x plus 1 to the negative 2, and find the derivative, which is use the chain rule by letting u be x plus 1. And so the chain rule is do the regular derivative, put the negative 2 in front of the x plus 1, and then subtract 1 from the exponent, and then times the derivative of the x plus 1, the part that we call u. So in this case, we let u be x plus 1. And then this becomes negative 2, and then x plus 1 to the negative 3. And then the derivative of x plus 1, derivative of x is 1, derivative of 1 is 0, so we get 1 plus 0, which is 1. And so this just becomes negative . And then we can rewrite this as negative 2 and then times x plus 1 to the negative 3 is the same as 1 over x plus 3 to the third. And so this becomes negative 2 over x plus 3 to the third. And so looks like the only critical number is where the derivative is undefined. And so we can see that if we put negative 3 here, then negative 3 plus 3 is 0. And then that will make this undefined. So negative, that should be a 1. That should be a 1. And then, so we put in a negative 1 right here. And then we have a negative 1 here. And then this will become negative 2 divided by 0, which is undefined. And so the function, the derivative here is undefined at x equal to negative 1. And so we say that the function, this function right here, is not differentiable at x equal to negative 1. And wherever the function is not differentiable, we call that the critical number. And so remember that to find critical numbers, we look at the derivative and see where it's undefined. And then the other thing that the other way to find critical numbers is by setting the derivative equal to 0. Now if we set this equal to 0, then the only way that this could be 0 if the top is 0. But the top here is always going to be negative 2, so it cannot be 0. And therefore the only critical number we have is negative 1. And then if we evaluate the function here at negative 1, or at the critical number, and we also get undefined. So what we have here is this: when x is negative 1, y is undefined. So that tells us that this value right here is indeed negative 1. And again, we can see that from the left side up to negative 1, the graph is going up. And then from negative 1 to the right side, the graph is going down. And so we say that the function, this function right here, is increasing on the interval from infinity to negative 1. And then we say that the function is decreasing or going down, or the graph is going down on the interval, that should be negative, on the interval from negative 1 to positive infinity. So from the graph, we notice that the function is increasing on the interval from negative infinity to negative 1, and then decreasing on the interval from negative 1 to infinity. So what that means is that if we pick any number from this interval, let's say like we pick negative 2, and then evaluate the derivative function here at negative 2, then we'll end up with something positive, because the function is increasing on this interval. And in fact, we let x be negative 2, and if we evaluate the derivative function here at negative 2, then in the place of x, we put negative 2. Then we have negative 2 dividing by, so in the we put a negative 2 right here, and so negative 2 plus 1 is negative 1, negative 1 to the third is negative 1, and then we have a negative 2 here, so negative 2 divided by negative 1 is positive 2. So once again, any number from this interval, and then evaluate it with the derivative here, then we'll end up with something positive. The reason because the function is increasing on this interval. And then here, let's pick 0. 0 is in this interval. And then if we evaluate the derivative at 0, then in the place of x, put 0. We get negative 2, and then 1, which is negative 2, which is negative. And so any number from here, from this interval, the derivative be negative if the function is decreasing on this interval.